Lesson 9, Tic Tac Toe. To follow along with this lesson, you will need to create a new empty console project and add a new C++ file named main.cpp to it. For this lesson, we are putting the material from the previous lessons together to write a simple game. The game that we are programming is Tic Tac Toe, and it uses a board that is numbered 1 through 9, like this one. On each turn, players enter a number to choose a move. To simplify the programming, we have assumed that player 1 always moves first and uses X's. Player 2 uses O's. Before we get to the code, I'll explain how the program is structured. Although there are quite a few lines, it really isn't that much if you look at it this way. At the start of the program, we initialize variables, then we run through the game loop until the game ends and the players choose to quit. The game loop consists of 3 steps: display the board, get the current player's move, and check whether the game is over. With that said, we'll get to our program. You can download the code for Tic Tac Toe from our website, zoax.net. This portion of code is the initialization that was mentioned. The variables for squares are initialized with the characters 1 through 9. The player turn is initialized to 1 since player 1 will take the first turn. Game over is initialized to true, but that doesn't really matter for this program. Recall that we covered this material in lessons 3 and 4. Incidentally, these lines of green text are just comments for programmers. They don't affect the execution. Comments are preceded by 2 slashes which tell the compiler to ignore the code. In longer programs, commenting is essential to help you or someone else understand and modify the code at a later time. After initialization, we begin the main game loop. This loop is a do-while loop which encapsulates all the code that is executed each turn. Once we enter the game loop, we print the board. These 5 lines display the tic-tac-toe board in the console window every turn. Remember that the squares were initialized with characters 1 through 9, so when we run the program, the board looks like this. Notice that the console window prompts the player for a move. The player's moves are handled by the next portion of code. Here we set the player's mark to X if it is player 1's turn, or to O if it is player 2's turn. Then we prompt the player for a move. The cn statement waits for the player's input. Notice that we've entered another loop. This loop runs until the player enters a valid move. The check for a valid move is pretty large since it has a branch for each square. Each branch of the if statement makes 2 checks. The first check verifies that the input is a digit 1 through 9, and the second check ensures that the square is still a number. The second check makes sure that no one has marked that square already. Once a player moves, the square is changed like this. If a player makes an invalid move, he is prompted to try again, like this. After a valid move is entered, a series of checks are made for an end-of-game condition. Note that there are 9 ways to end the game, 8 win conditions and 1 draw. The first if statement contains the 2 win conditions that run through square 1. The second if handles 4 cases through the middle square. The third if handles 2 cases through the 9th square. In each of these cases, we check that the square is not equal to its number character. This check ensures that we have an X or an O in this square. Then we check whether the other 2 squares in the series are the same as this one. Those cases cover the win conditions, however, games often end in a draw like this. This final check takes care of the case of a draw and checks whether all the squares have been marked. Once we have determined whether the game is over, we run through our final conditional. If the game is over, we check whether someone has won via the win game boolean, which we set in the last part. If someone has won, it must be the last player to have moved. After that, we print the game ending board to the console and ask whether the players want to play another game. If the players choose to continue playing, the game over flag is set to false to continue looping and the board is reset. The player's turn is also set back to player 1. On the other hand, if the game isn't over, we alternate the player's turn and return back to the top of the game loop. This concludes the lesson.